Let's do our second example on this Pythagorean theorem doodle notes page. Um, Once again, we have a right triangle, and I'm going to highlight the legs. So I keep saying the same thing over and over again, but the legs are the two sides of the right triangle that come together to make the right angle. Okay, so it has to be these two sides here that are labeled X, and one is also labeled 8. And then the hypotenuse of this triangle, which is the longest side, and it's the side that is opposite of the right angle, is this one that I'm highlighting in blue that has a label of 13 feet. Okay, so we're going to once again use the Pythagorean theorem to figure out the length of the unknown side. However, on this example, you will notice that we know the length of one leg, but we do not know the length of the other leg. So the previous example that we did, we had to figure out the length of the hypotenuse, and this time we're actually going to figure out the length of the leg. So it's a little bit different. So once you've established which of your sides are legs, you pick one to represent A and you pick one to represent B, and you plug them into that formula. A squared plus B squared equals C squared. So looking at my two legs, the A and the B, one of them is an X. So let's just go ahead and call X A. So that one I'm going to say is X squared. And if we pick the X to represent the A, then that means we're going to pick the 8 to represent the B. So that one's going to be 8 squared. And the hypotenuse is the C, so that we're going to replace the C with 13 squared. So this time the solving of the equation is a little bit trickier, but not too much trickier. You're going to solve this equation the same way you would any equation, following order of operations. So let's go ahead and figure out what is 8 squared. 8 squared is 64 because it's 8 times 8. And 13 squared is 169. All right. Our next step, we're trying to isolate that X because that's what we're trying to solve. So before we deal with that square or that exponent, I'm going to go ahead and subtract 64 from both sides of the equation. So if I subtract 64 from 169, I get 105. So now my equation is X squared equals 105. And remember, using inverse operations, we're going to, the only way to undo squaring a number is to take the square root. So if I take the square root of the left side, squaring and square roots are inverse operations, so it cancels it out. And then I'm going to take the square root of 105 to figure out X. So using my calculator, because I don't believe that's a perfect square, I'm going to take the square root of 105 and I get 10.246950077. It keeps going forever, but I'm going to round my answer to the nearest tenth. And I'm going to get, I got to go look back and see what my units are. My units are feet. So the length of X is approximately 10.3 feet. And I could check that. I should check that. Let me extend the page here by plugging that back into the original equation. 10.3 squared plus the other side was 8, so 8 squared should be close, approximately equal to 13 squared. So now with my calculator, I'm going to do 10.3 squared. Again, I'm kind of rounding here because I rounded before. Oh, actually, I didn't round that, but the 10.3 is rounded. And then 8 squared is 64. And then 13 squared is 169. So when I add 106.09 plus 64, I should get something pretty darn close to 169. So 106.09 plus 64, I got 170.09. And again, it's not exact because of that rounding above, but it verifies.